You have probably heard these terms before: preload, prefetch, lazy load, and so on and so forth. This sounds familiar, and in different places, browser, HTML, JavaScript libraries, or frameworks like Relay, they show up again and again. But what do they actually do? And more importantly, how do they help you design a faster, smoother front-end UI? In this episode, I will walk you through the difference between those terms: preload, prefetch, dns-prefetch, how tools like React Query, SWR, or Relay preload data, and the real-world examples like hover, trigger, dialog, and prefile cards. By the end, you will know what to use, when to use it, and why it matters. Not just in theory, but in practice. You will see how preloading the right code or data at the right time can make your application feels instant, reduce the number of spinners, and avoid costly delays. So modern front-end apps are often break down into many JavaScript bundles: your main application logic, third-party libraries, feature modules, and more. This helps keep initial load time low, but it also means that when a user clicks a button or pop-up open a modal dialog, there might be visible delay as the browser started to loading everything. But what if we could shift that loading earlier? What if we could tell the browser, hey, this is a JavaScript file, this font, or this API call is likely to be needed very soon. Start getting it ready now. That's what preload, prefetch, and lazy load aim to resolve. Whether it's using declarative browser hints like the link tag with a preload, or JavaScript-based preload functions in libraries like SWR, React Query, and Relay, those tools help reduce perceived latency and create snappier interactions. In this video, we will walk through the different types of preloading, how they work under the hood, and when to use each, so you can build faster, smarter front-end systems. Let's start with declarative preloading in native approach in browser. Modern browsers allows you to express your intent directly in HTML using tags like link, rel equals to prefetch or preload, and the browser decide the optimal way and time to act on it. They complement JavaScript-based solution and help the browser act earlier, even before any JavaScript executes. Placing them in header in an HTML document give the browser a head start to warm up critical resources while passing the HTML. Let's start with the link with preload as the real attribute value. So this tells the browser to start downloading earlier, even before the actual script tag appears. Use this when you are loading classic JavaScript scripts or fonts, images you know will be needed soon. And there's a related value for the rel on the link tag, which is a prefetch. This tells the browser to fetch the resources when it's idle, without blocking critical tasks. Use this for resources that might be needed soon, like the next page scripts or a component, but not immediately. And there is a dns-prefetch value as well. This will start DNS resolution earlier, before any JavaScript initiates the request. This is used for when your app needs to contact a third-party API or separate domain for data, so that DNS resolution is out of the way when the actual request happens. Let's dive into it. So the application we are going to use for demonstrate these ideas is a profile page. Basically, there is a user section, and there is a friends of this user section. And when you hover on this, there will be a pop-up. And then at the end of the page, there is also a list of feeds. You can think of that as a feed list or something like that. A user might interested in that profile or like a homepage or timeline page. And there are a few network requests for fetching this information showing on the page. And at the moment, if we go to the code Actually, I have implemented several versions of this profile, and we're using the fifth version of it. If we open up the profile, you can see there is a use effect block that will fetch the user and friends in a use effect block. It will send two requests simultaneously to get the user by ID and also the friends of that user by ID as well. And during the loading status, it will show a user info skeleton, and if something went wrong, it will show an error message. And then once we have that user info, it will pass the user to a about a section, which is essentially this name and description and avatar. And then there is a friends list that will use the friends array. It will show these three friends, and then at the bottom there's the feeds, which is corresponding to this section. And I have added a few fixed delays for this API endpoint. So when we are hitting to this API, it will have a few seconds delay. That's pretty much about the setup. And if we now go to the page and do a refresh, you can see that some skeleton shows up first on these user and friends, and then your feed list. Let's do it again. If I inspect the network and do a refresh of the page, and you can see that the localhost is HTML document is loaded first, and then in it has the reference to the script. So the index.js is loaded, and the index.css is loaded as well. And later on, as we have the JavaScript, the user API and also the user friends API are kicked off simultaneously. And then there will be some other resources loaded as well. But you can see that there is a clear timeline here. If I use the performance tab instead, let's do another refresh to profile the current implementation. We can see that if I zoom in the network here, so you can see the HTML document is kicked off at this point, and then index.js and CSS, and there's some passing work here, and then the user and the friends requests are kicked off. So there's some gap here. You can see there's some delay. It's not very obvious when you refresh the page to see that delay, but when you profile it, you can see that much cleaner in here. Because the API call is time consuming, it has some significant delay. What if we can make that happen earlier on the timeline? So that's where the preload tag come in. So if we go to the index.html and in here, so before the script and every other resources, we can ask the browser to preload the API. So basically we'll do a link tag with the rel equals to preload. And we want to treat this preload as a simple fetch. And for the cross-original, we just put that anonymous. And the reference for this will be the URL we are sending the request to. And we want to send the request to this endpoint at very earliest stage in here, like so. So this basically tells the browser to preload this resource as early as possible, even before the script or the CSS. And also we want to load the friends for this user as early as possible. And with these tags, if now we go back to our browser and do another refresh to profiling the current change. So you will notice here that as we are sending the request for the HTML document, the user API and the friends API are kicked off instantly, along with the index.js and index.css. That moved the load much earlier, so that will be resolved earlier, so we have a faster UI alternately. And if we go back to our application, doing a refresh, we can see some slightly faster UI here. And in the network tab, we can see that the user and friends requests are sending out very earlier. After the document, right away we have this user and friends sending out. And if we inspect this column here, open up the priority, you can see that the HTML document has the highest priority, and then we have this user with a high priority, and also the friend has a high priority. And also you can see that the HTTP request happened much earlier than the index.js and the CSS. That's why it will render much faster. So why not use preload for everything if it's that good? Because the preload is treated as high priority by the browser, it starts downloading immediately, competing with critical script and assets. If the preloaded resource is not used soon, it can hurt initial performance. Use wisely to strike the right balance. And also we noticed that there are some third-party domains we are accessing for the user avatar. These images are from the preavatar.cc, this domain. And if we want this happen earlier, we can put this DNS into a link as well. So basically we can implement that by saying link. The rel is dns-prefetch, and we want to provide that ref to this domain. So what it does is it will try to resolve this DNS name to the IP address as early as possible. So when we actually accessing these images or loading the images in a user avatar, they'll be much faster because the DNS has already been resolved. So this is where you use the dns-prefetch. It might not very noticeable in our case here because we have already have cache. The DNS has already been activated as we are accessing. But you got the idea, especially for the first time when user accessing your application, well, your application is accessing some third-party domain, which you haven't in your browser accessed before. And that dns-prefetch will make your application much faster. This is a declarative way to implement the preload. And we call it a declarative. What does that mean is that you describe what should happen, not how. In HTML, you say, I want this resource loaded earlier, and the browser figure out how and when to do it. Same in React, you declare the UI, React figure out what to render. This model makes the code easier to reason about and give the browser or framework flexibility to optimize under the hood. You should consider using the native browser-based approach whenever possible. It's simple, reliable, and give you performance benefit out of the box without worrying about polyfills or compatibility problems. But when native options don't quite fit, like when you want to preload resources conditionally based on user behavior, this is where JavaScript-based solution come in. Libraries like SWR, React Query, or Relay let you preload dynamically in response to user interactions like hover or scroll. Those tools give you more control and flexibilities to optimize performance precisely where it matters. Let's now have a look at this in action. So for example, in the friends list avatar, there is an avatar here. When you hover on it, we want to load the data for this user detail. And when you click it, it will open the modal dialog to show this user's detail information. And for such case, we cannot predict the user will click that because they may not click the particular friend at all. So we want to dynamically at this point to load this data and the JavaScript bundle for this modal dialog or this pop-up. So that can be implemented in a different approach with the JavaScript preloading. React provides a built-in API for code splitting with React.lazy and Suspense. It allows you to load components only when they are needed and show a fallback like a spinner or skeleton component while they are doing the fetch. If you're new to this pattern, I actually had the whole video covering the React.lazy and the Suspense in depth. Check them out first if you would like a refresher. Let's forget the declarative approach for a little bit and go to our application and the profile. And now if we go to a friends list, and we can see that in here I'm using the React.lazy and the Suspense API combination to make this a lazy loading. So basically, we are importing this friend.tsx so that it will be bundled in a separate bundle, and the Suspense API will work with this lazy bundle. And during the loading experience, it can show a skeleton, and once the friends is loaded, it can finally use the data. So if we go to the friend component, there's a popover component that has a trigger and a content. So basically, this trigger is like a button. We click, and then it will show up the content of this user detail. So in here, we have a brief component that is using the user that is wrapped inside a button, a headless button. So we have defined a on-mouse enter here. Basically, it will trigger the mouse enter handler whenever a user hover onto this trigger, which is the user avatar here. So if we inspect the component, let me put this into the bottom of the page, like so, and do a refresh. Let me clean the network. So if I hover on the avatar, immediately you can see a details API is triggered. So that will load the details for the user 2. And if I hover on the other one, the Bob Smith, it will load the user 3. This happens because we have a preload from SWR, which is a library that can maintain a cache that has the API path to data mapping. You can think of that as a hash map or something like that. And the key of that map is the API path, and the result is the response from the server side. So that means when we handle mouse enter, we'll preload this cache or refresh the cache under the hood. That means that we'll download the details into a local in-memory cache. So, and inside the user detail card, which is the place where we use the data, if we go to the user detail card, we are using the use SWR for this particular key, and because the data has already been downloaded while we mouse enter it, so in here in the user detail card, it can get this data right away from the cache. It's already there. And then it can use the data as the details to show the header in the paragraph as well. So that's why you see that so quick. So when you click it, you can see that data immediately. So that means when you hover, it will download or preload the data, and when you click, it will open up this modal dialog with the data already fetched. And there is one more request sending out while we open up this modal dialog, which is the image. If we can cache the image somewhere in the local, that will make the user experience even better. For example, at the moment when we click it, it will always load the image from scratch. But yeah, we can enhance that experience by caching this data or the image data somewhere. Because the cache is maintained by SWR, it can handle all the deduplication, the cache invalidation, all these, even cancellation under the hood automatically. That can save us quite a lot of effort on the maintaining this preloading behavior. Similarly, in React query, in Relay, they have the similar implementation details. Basically, they have a big map or a hash store in the browser memory. And when you hover or scroll to trigger a network request, it will first look up in the cache first and see if there is already a data. And you can use this data from the cache immediately to show something on the screen. Under the hood, it will send another request to invalidate the cache. And once the response is back, the library can refresh the cache and the UI will be refreshed again automatically. This is how you do that preloading with React libraries. It's a little bit more complicated than the link declarative way, but it also gives you more control, more flexibility to do that with code. And if you want to look into the every code implementation details, I have already published a tutorial in my website, icoded.com.au, and there is a tutorial here which is talking about the advanced data fetching patterns in React, and you can see that prefetching techniques in React applications. It has more detailed explanation in the article. Please feel free to have a look and let me know if you have any following up questions. So those techniques are most useful when you can confidently predict the user's next step. Modal or dialogue that opens on user interactions, the product card with a quick review or preview, router transitions between large pages. They can significantly improve the perceived performance by getting results earlier before the user even notices a delay. And on the other hand, there are cases you shouldn't use them. So be cautious in these situations. For example, if you have a heavy data and large JavaScript chunks the user might never use, but you decide to preload it. Or some mobile devices on a slow network and unpredictable user paths where prefetch guesswork goes wrong. Overusing prefetch or preload can backfire, wasting bandwidth or even slower down the critical path. So they are not just like technical terms, fancy words. They are your performance levels, tools that let you take control of the user experience by reducing perceived waiting times, minimize the layout shifts, and improving responsiveness. If you've done that right, they make your UI feel faster. They help to anticipate what the user might do and meet them there before they even click. If you learned something today, leave a comment below, and I'd love to hear how you are using these techniques. And if you are into building faster, scalable front-end systems, hit subscribe. I have got more practical episodes coming soon. Thanks for watching, and I will see you in the next time.